This is section 7.3, computing the values of trig functions of acute angles. There will be one page that we're going to skip, and there's going to be two videos, part A and part B. So this first one is part A, obviously. Alright, so the first objective is finding the exact value of a trig function of 45 degrees, or in radians, pi over 4. Alright, an isosceles right triangle has two equal sides and two equal angles. The measure of the two equal angles are, that's what that's supposed to say there, 45 degrees, or in radians, pi over 4. The sum of the interior angles of any triangle is 180 degrees. So that's why this works. One of our angles is 90 degrees, and then plus the two 45 degrees will give us 180. By the way, that's the definition of a triangle. The interior angles have to sum to 180. All right, so if we start with an isosceles right triangle, we know that it has two equal angles, both are 45 degrees. And we know the sides have to be equal as well. So if we make those 1, we get 1 on one of the legs and 1 on the other leg. To find this missing side over here, what we're going to use is Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared, which means we take the first leg and we square it, plus the second leg and we square it, and it equals the hypotenuse squared. So I don't know what the hypotenuse is yet, so I'm going to leave that as c. So if I do the math, I get 1 plus 1, and it equals c squared. 1 plus 1 is 2, which equals c squared. Solving for c, we get the square root of 2. By the way, we actually have two answers. It's plus square root of 2 and minus square root of 2. Because I'm talking about length, I'm just going to use the positive square root of 2. All right, so now I have my isosceles right triangle, and we're going to be using this to find the trig functions on the next page. All right, so at the bottom of page 1, it says, now use one of the 45-degree angles to determine the 6 trig functions. Remember the fundamental identities, they will help make your life a little easier. Okay, I'm going to write up here, SOHCAHTOA. Just as a reminder. And I'm also going to redraw the 45, 45, 90 triangle. Remember, these are in degrees. Okay, so there's my triangle. I'm going to go ahead and find sine first. So sine of 45 degrees, or pi over 4, is opposite over hypotenuse. So if you look at either of the angles, the opposite side of 45 is 1, and the hypotenuse is radical 2. I have to rationalize that. So to rationalize it, what I do is get rid of the radical in the denominator, and we get radical 2 over 2. All right, first value is done. Second value, cosine of 45 degrees. Cosine is defined as adjacent over hypotenuse. The adjacent side is 1 over the hypotenuse, which is radical 2. So once again, if we rationalize that, because that's the same value we got before, we'll get radical 2 over 2. Okay, tangent of 45 degrees is opposite over adjacent. The opposite side is 1, the adjacent side is 1. So 1 divided by 1 is 1. All right, got 3 more to go. The reciprocal function of sine is cosecant. And cosecant, by definition, because it's the reciprocal sine, is hypotenuse over opposite. The hypotenuse is a radical 2, and the opposite side is 1. So radical 2 divided by 1 is radical 2. Secant of 45 degrees. Secant is the reciprocal function of cosine. So it's defined as hypotenuse over adjacent. The hypotenuse is radical 2, and the adjacent side is 1. So when we divide these two, we get radical 2. And finally, cotangent of 45 degrees. Cotangent is defined as adjacent over opposite. The adjacent side, no matter which 45 degrees you're looking at, is going to be 1 over 1, which is just 1. Okay, so that's finished. Let's go ahead on to the next page. Objective 2, finding the exact values of the trig functions of 30 degrees, or pi over 6, and 60 degrees, or pi over 3. An equilateral triangle has 3 equal sides and 3 equal angles. Each interior angle is 60 degrees. I get that by taking 180 and dividing it by 3. And if I add those 3 angles together, or take 60 degrees multiplied by 3, we get 180 degrees. So if I start with an equilateral triangle, remember all sides are equal, all angles are equal. And we have to make an assumption here that all sides are 2 for this to work out for us. Okay? So what we're going to do with this triangle is literally cut it in half, and we're going to make the cut right here. Okay, so let's look at the next page. Alright, so we're going to cut that 60-degree equilateral triangle in half. Once again, I told you we're going to cut it in half. The base of the triangle is right here. Okay, so if that length was 2, and I cut it in half, now each piece is 1. Okay, this side here is going to remain 2 because I didn't do anything to it. And I don't know what this side is, so we're going to have to use Pythagorean theorem to figure it out. And remember, that's a leg. So when I cut it in half, it makes a nice triangle. So we have a right triangle, 30, 60, 90. And we know this is 1, 2. We got to find that missing side. Okay, so I'm going to use Pythagorean theorem again. A squared plus b squared equals c squared, where a is 1, b is the unknown, so we'll leave that as b, and c is 2. So I get 1 plus b squared equals 4, b squared equals 3, b equals radical 3. So I just found that missing side to be radical 3. Okay, I'm going to fix that. There we go. Okay, so we're going to use this triangle now to find the 30, 60, 90 values of sine and cosine. All right, so we're going to do 2 values, 30, 60, 90. I'm going to focus on the 30 degrees first. Okay, so I highlighted that. Once again, my sides are 1, 2, radical 3. And we're going to find all the trig values for the 30 degrees. So sine of 30 degrees, once again, remember that 30 degrees is pi over 6, just as a reminder. Sine is opposite over hypotenuse. So the opposite is 1 over the hypotenuse, which is 2. Cosine of 30 degrees. Cosine is defined as adjacent over hypotenuse. So the adjacent side is radical 3 over the hypotenuse, which is 2. Tangent is defined as opposite over adjacent. The opposite side is 1. The adjacent side is radical 3. If I rationalize that, I'm going to get radical 3 over 3. Okay, now we need the reciprocal functions. So sine's reciprocal function is cosecant of 30 degrees. Remember, that's defined as hypotenuse over opposite. The hypotenuse is 2. Opposite side is 1, so this equals 2. Secant is the reciprocal function of cosine. It's defined as hypotenuse over adjacent. So that's going to be 2 over radical 3. If I rationalize that, I get 2 radical 3 over 3. And finally, cotangent, which is the reciprocal function of tangent. It's adjacent over opposite. So that's radical 3 over 1, which is radical 3. Okay, now let's go ahead and look at the 60 degree. So I'm focusing on the 60 degree here. And we're going to find all the values. So sine is 60 degrees, once again, opposite over hypotenuse. SOHCAHTOA. I'm writing that up there for you. So opposite over hypotenuse would be radical 3 over 2. And that one's done. Cosine of 60 degrees is adjacent over hypotenuse. Adjacent side is 1 over the hypotenuse, which is 2. Tangent of 60 degrees is opposite over adjacent. The opposite side is radical 3. The adjacent side is 1, which equals radical 3. Cosecant of 60 degrees. Remember, that's the reciprocal function of sine. So by definition, it's hypotenuse over opposite. The hypotenuse was 2. The opposite side is radical 3. So we need to rationalize that. So that becomes 2 radical 3 over 3. The reciprocal function of cosine is secant. Hypotenuse over adjacent. The hypotenuse side is 2. The adjacent side to 60 degrees is 1. So this equals 2. And finally, cotangent of 60 degrees is adjacent over opposite. The adjacent side is 1, and the opposite side is radical 3. So if we rationalize this, we get radical 3 over 3. By the way, on your test, you will be expected to rationalize all the values. This is very important because when you get to calculus, you have to be able to rationalize. So I just wanted to give you a heads up that for you to know that I expect that. Okay, we're going to skip the use your left hand to figure out the values of sine and cosine, and I'm going to do these 2 problems here. Okay, and then we'll pick up on that page halfway through. So let's just do these 2 problems. The first problem requires us to know the 45, 45, 90 triangle. So I put the triangle, I wrote it down for you. So, whoops, sorry about that. So we're going to find sine of 45 degrees first. And remember, sine is opposite over hypotenuse. The opposite side would be 1 over radical 2. So this is radical 2 over 2. Okay, we have to also find tangent of 45 degrees. Tangent is opposite over adjacent, which is 1 over 1, which is 1. So if I put this together, sine of 45 degrees times tangent of 45 degrees, I get radical 2 over 2 times 1. That equals radical 2 over 2. There's your answer. Okay, second one. Pi over 4 is 45 degrees, so I'm going to use a triangle I just wrote down for part A. So we're going to find secant of pi over 4. Secant is a reciprocal function of cosine. So by definition, this is hypotenuse over adjacent. The hypotenuse side is radical 2. The adjacent side is 1, so this is radical 2. Cotangent is a reciprocal function of tangent. So by definition, it's adjacent over opposite. So 1 divided by 1 equals 1. So let's put the pieces together. Secant of pi over 4 times cotangent of pi over 4, remember pi over 4 is 45 degrees, is radical 2 times 1. Radical 2 times 1 is radical 2. So there's your answer. Okay, I know I'm halfway through the page. I will pick up on part B of this section in the next video.